Welcome back. Well, looks like this question is going to take the whole lesson. A very interesting question. It would be a 16-mark question, I think. Parametric equations. Part A says, find integral cos squared to theta. I'll do this and write the answers there so that we can go through the next part later. So let me do that. It's an even power of cos. Anytime you want to integrate an even power of cos or sine, use double angle formula. So cos squared is 1 plus cos 4 theta over 2 d theta. That is a half of theta plus quarter sine 4 theta. So this one is, I need the answer, that's why I'm keeping it, half of, or I can open the brackets, half theta plus 1/8 sine 4 theta. Understood? We did this before, or you learned it in your class before in case you had watched what I did before. Right? Let's do part 2. Part 2 says integral cos cube 2 theta d theta. Remember when we went, your teachers will have told you, or you've gone through the lesson I did on integrating trigonometric functions. Whenever you have an odd power of sine or an odd power of cos, split it as 1 and an even power. So cos cube I can write as cos squared 2 theta times cos 2 theta d theta. Why? That's the only way, because then I can convert cos squared to sine squared. I can use inspection or substitution. So integral 1 minus sine squared 2 theta times cos 2 theta d theta. When you differentiate a sine, you get a cos. So you have a function and its derivative. So therefore that becomes, I'm going here, sorry, up and down, that's how I used to teach even in school. Hope you're not very confused. So it's integral 1 minus u squared times du over 2, because d theta cos 2 theta d theta becomes du over 2. So that is a half of u minus u cube over 3, which is half sine 2 theta minus 1/6 sine cube 2 theta. So let me write that. Half sine 2 theta minus 1/6 sine cube 2 theta. Let's read the next bit of the question, because I need to rub it off to do all the work. That's why I kept that small bit there. See, this particular region, which is shaded there, is rotated like this. You're asked to find the volume. How do you do volumes when the parametric equations? Remember, you write the formula as pi integral y squared dx or pi integral x squared dy, nothing wrong. And then substitute for y in terms of t, substitute for dx in terms of dt, change the limits from x to t, and then integrate. So therefore, and when I do all that, you are expected to come to that answer. That's what they're saying. Let us see whether it comes to that. Look, first and foremost, at this point, what is the value of t? At this point, t is 0, because x is 0, y is 0. When y is 0, 1 minus cos 2t is 0, and then cos 2t is 1. So 2t can be 0 or 2 pi. So therefore, it has to be 2 pi. It can't be 0. If 2t is 2 pi, is 2t is 2 pi. So that should have been 2 pi. 2 pi 0, not 4 pi. So therefore, x is 2t is 2 pi. So look, y is 0. I get 1 minus cos 2t is 0. So cos 2t is 1. So therefore, 2t equal to 0, 2t equal to 2 pi. So t equal to 0, t equal to pi. Correct? So I think I copied the question wrong. I made up this question, 0 to pi. So therefore, and x will be 2t minus sine 2t. So that is 2 pi minus sine 2 pi, which is 2 pi. So I got the answer correct. So therefore, the volume, remember, write the formula in terms of volume equal to pi integral 0 to 2 pi y squared dx. First, what is y squared? Y squared will be 1 minus cos 2t the whole square. What is dx by dt? Dx by dt is 2 minus 2 cos 2t, or 2 times 1 minus cos 2t dt will be dx. And t equal to 0, x equal to 0, t equal to pi, x equal to 2 pi. Yeah. So therefore, volume becomes pi integral 0 to pi y squared is 1 minus cos 2t the whole squared times 2 times 1 minus cos 2t dt, which becomes 2 pi integral 0 to pi 1 minus cos 2t the whole cube dt. That is how you show it. You get about 2 or 3 marks for that. Not even 3 marks. I think you get about 2 marks to do that. Very good. The next job is to find that integral, which is where life becomes very interesting. What is integral 1 minus cos 2t the whole cube dt? One way of doing it will be 1 minus cos 2t is 2 sine squared t. It becomes sine power 6. And you don't know how to integrate sine power 6. Yeah? Because it's all even powers. And you don't go beyond 4, because then you have to have a triple sine 3a and cos 3a formula, which I'm sure most of you may not even know. So therefore, we must look at, you understand what I'm saying? Look, I could do this as integral half 1 minus cos 2t is 2 sine squared t the whole cube becomes 8 sine power 6 t dt. How are you going to integrate sine power 6? Yeah? You can't integrate sine power 6. You can't write as power 5 and 1. No, doesn't work. And if you try to use double angles, I'm back to this one only. So therefore, the only way we can do it is by expanding this. And remember, whenever I talked of a question, even before, whether it was algebra, whether it was differentiation, trigonometry, tangents, normals, anything, generally, if a question has part A and part B, 99.9% of the cases, part A has something to do with part B. So it's not for nothing that you are asked to do this. Let us see if that works. What is A minus B whole cube? Integral 0 to pi. 0 to pi. It is A1 cube minus 3 times 1 squared times cos 2t plus 3 times 1 times cos squared 2t minus cos cube 2t dt. Still don't see the link? Integrating cos squared, I have the answer. Integrating cos cube, I have the answer. That was the reason why when I made this question, I put these two first. That's how they do it in the exam as well. Because we don't expect you people in under pressure to think. So what we do is we give you this, so at least you remember part A has got something to do with part B. So I need to get a cos cube. I need to get a cos squared. The only way I can get a cos cube or the only way I can get a cos squared is by expanding this. So that is 2 pi times integral 0 to pi 1 dt dt minus 3 integral 0 to pi cos 2t dt plus 3 integral 0 to pi cos square 2t dt plus minus integral 0 to pi cos cube 2t dt. Ha ha! So let's do this. That's 2 pi times. It's t between 0 and pi minus 3 over 2 sine 2t between 0 and pi plus 3 I have there half t plus 1/8 sine 4t between 0 and pi minus I have there half sine 2t minus 1/6 sine cube 2t between 0 and pi. You see, all your integration you've done in the beginning. It's a question of substituting and saying the link. So that will be, where shall I write? Now I can rub this off. We don't need this. So I'll write the answers there. Good. So when you put as pi, that's pi times pi minus 0 minus 3 over 2 times sine 2 pi minus sine 0 plus 3 times half pi plus 1/8 sine 4 pi. 1 plus cos 4, 1 plus cos 4 theta, so half of, so that's correct. Sine 4 pi minus 0. Okay, minus 0 plus 1/8 sine 0 minus half sine 2 pi minus 1/6 sine cube 2 pi minus half sine 0 minus 1/6 sine cube 0. I don't have to write that, but I'm just writing it for the sake of completeness. Look, all these are zeros. Where's my colored pen? This is 0, that 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 is 0. All of them are 0. So what are you left with? You're left with pi times pi plus 3 pi by 2. 5 pi squared over 2 is, there was a 2 pi, sorry, there was a 2 pi. There was a 2 pi, not a pi. So 2 pi. So 3 pi by 2 plus pi is 5 pi by 2. Multiplied by 2 pi is 5 pi squared. That is the volume. 14 minutes. Good question. So in other words, whenever you have a question which has parametric equations, you must write the formula for area or volume in terms of Cartesian equation. Don't straight away put the dt. Y dt. No, it's always integral y dx or integral x dy or pi integral y squared dx or integral pi x squared dy. Having done that, substitute for y or x in terms of t, dy or dx in terms of functions of t and dt, and then change the limits and then integrate. And you need to be good at it. That's the reason why I love this question, because you go over various aspects of integration. I have one more question which is equally bad, which I'll do in the next lesson. I'll see you later. Have a nice day. Bye bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded, and launched. Thank you very much.